direction and the y direction. The movement of an object in both the x direction and the y direction. So the number on top in the column vector, let's go back to our vector AB, which we wrote as 2, 3. The number on top represents the movement in the x direction. And the movement in the x direction is the horizontal movement. The 3 will represent movement in the y direction. And that will be the vertical movement, up or down. The x direction, you can either go to the left, to the right, or to the left. So for the number on top there, it moves horizontal movement. The number below, the component 3, will mean vertical movement, either up or down. So in this vector AB, 2 means 2 units in the x direction. And then 3 means 3 units in y direction. Whenever you are moving in this manner, always start with the x movement. Do not start with the y movement. Always you start with the x movement. In the vector AB 2, 3, 2 means 2 units in the x direction or the x axis. Then 3 means 3 units in the y axis. Movement in the y axis. Now, if I have vector PQ, which is -1, 5, what does the -1 mean? The -1 will mean 1 unit in x direction. And then 5 will mean 5 units in y direction. Fine. I've said -1 means 1 unit, but there is a negative. So that negative has a meaning. Let's talk about negative components. If you have negative components in a vector, what does the negative mean? So negative components. Movement in the x direction can either be to the right or to the left. When you move in the right direction, that movement is taken as positive. When you move to the left, the movement is negative. So I'll write here, movement to the right in the x direction is positive. Movement to the right in the x direction is positive. Then movement to the left is negative. Movement to the left is negative. Going back to our vector PQ, negative 1, 5. The negative 1 will mean 1 unit to the left in the x direction. The 5 means 5 units in the y direction. So in the x direction, when you move to the right, you take that as positive. When you move to the left, that is taken as negative. In the y direction, movement upwards is positive. Movement upwards. Let me write upwards in capital. Movement upwards is positive. Then movement downwards in the y direction is negative. So our PQ, vector PQ, negative 1, 5. This means you move 1 unit to the left in the x direction. Then 5 units upwards in the y direction. So in the y direction, movement upwards is positive. Then movement downwards is negative. Movement downwards is negative. Okay, let us just have a few examples to show what we mean by the positive and negative movements. Example 1. Let me have vector A, or let me use a different letter this time, vector B. Let this be equal to negative 3, negative 4. We have negative components there. So the negative 3 means 3 units to the left in the x direction. 3 units to the left. Negative 4 will mean 4 units downwards. Remember we said negative in the y direction means downward movement. This means 4 units downwards. Fine. Another vector we can take is vector xy. Let this vector be 3, negative 2. The 3 will mean 3 units to the right. There is no negative now. So 3 means 3 units to the right. The negative 2 means 2 units. Two units downwards. Let us now see these negative and positive movements on squared paper. In our diagram, we have a number of vectors drawn using small letters. The first one is vector A, drawn on this squared paper. Now the question here says, write down the following vectors in component form. So we shall write each of these vectors in component form. Remember the term we said, usually we shall say write the following vectors as column vectors. So when we say column vectors, it means you write the vectors in component form. We shall look at vector A. Whenever you are writing a vector, given a directed line segment, look at the arrow. The arrow for vector A shows that I'm moving from this starting point to that end point. So that is the nose, the tail, and that is the nose. Now let us write this vector in component form. The starting is from here. We are ending there. So say we start by moving in the x direction. So I'll start from here. I'll count how many units to the right. This is 1, 2, 3. So I've moved 3 units to the right. Then 1, 2, 3, 4. 4 units upwards. So 3 units to the right. I'll write it as positive 3. 4 units upwards. I'll write it as positive 4. So vector A, as shown on our diagram, in component form is 3, 4. 3, 4. Remember, this type of movement, where you move in the x direction and y direction, is also known as translation. Translation is a sliding movement. You are moving in the x direction and then you move in the y direction. So a translation is also a column vector. You have done maybe that in transformation. Let's look at vector B. The starting point is here, and then we are moving to the nose. So for me to get there, I'll first move to the left and then move upwards. You always follow the arrow. So vector B, let's see how many units you move to the left. Our starting point is here. So I'm moving 1, 2. Then 1, 2, 3, 4, 5. So vector B as a column vector is negative 2, 5. Negative 2, 5. Meaning you moved first 2 steps to the left and then 5 steps upwards. So vector B as shown in the diagram there is negative 2, 5 in component form. How about vector U? The tail is there and that is the nose. How is the movement? I'm moving 3 steps to the left. So I have 1, 2, 3. You can see 3 squares. I've moved 3 steps to the left. So I'll write negative 3 for the x movement. How about the y movement? When I move from my starting point to there, I haven't moved in the y direction. I've just moved there in the x direction to the left. So since there is no movement in the y direction, we write that as 0. So that vector u is negative 3, 0. Simply means you have moved 3 steps to the left. That's all. You haven't moved in the y direction. How about vector v? My starting point is here and have moved straight up to the nose there. You can see that in the x movement, there is no movement. You are just starting from this and then you start going up. So the x movement is 0. How about the y movement? We are moving upwards, so we expect a positive value. So I'll count the number of units from my starting point. This is 1, 2, 3, 4, 5. So vector v as a column vector is 0, 5. Meaning no movement in the x direction, but 5 units in the y direction. Similarly, vector q, which will be our number 5. Vector q, you can look at the arrow. The movement is from here to there. So I'll first move to the left and then downwards. So we move 1, 2, 3, 4 to the left, and then 1, 2 downwards. So this vector is -4, -2. Vector Q is -4, -2. Vector P, you first move 1 to the left and then 3 upwards. So vector P will be -1, 3. -1, 3. So when you are given any vector drawn as a line segment on a squared paper, you are expected to give that vector as a column vector. The last one, which is vector R, you can see to move from the tail to the nose, you first move 2 steps to the right and then 1 step upwards. So vector R is 2, 1. That is vector 2, 1 as a column vector. So this is how the components are written. The negative number simply means moving either to the left or downwards. If it's in the x direction, you move to the left if the number is negative. In the y direction, you move downwards. I have some other vectors written here. I want to give you an exercise. So I'll write a question. Just take a piece of paper and write these vectors in component form. I'll have vector AB, vector BC, CD, DE, EA, and then I'll include some other vectors like BD. So let me write the question. I'll pause as you prepare yourself getting writing paper. Here is the question for the exercise. The question says, write each of the following vectors as column vectors. And all the vectors listed down will be based on this diagram, which is A, B, C, D, E, A. So you follow the arrows as you write down the vectors in component form. I'll give you 3 minutes to do the exercise. What was your answer for vector AB? On the diagram, to move from A to B, you first move 2 steps to the right, and then 1, 2, 3, 4 steps upwards. So vector AB as a column vector will be 2, 4. What about the movement from B to C? Our starting point now is at B. So to move from B to C, you can see the diagram there. You can move 1, 2, 3. Wait a minute. I'm moving 1, 2, 3 steps and then 1 unit. So I'm moving 3 steps to the right and 1 unit upwards. So vector BC is 3, 1. The next one, moving from C to D. To move from C to D, remember we said we always start with the X movement, the movement in the X direction. So to move from C to D, I'll first move 2 steps to the left, and then 1, 2, 3, 4 steps downwards. So CD will be -2, -4. -2, -4. 2 steps to the left and 4 steps downwards. DE. To move from D to E, I'll first move 3 steps to the right and then 2 steps downwards. So vector DE will be 3, negative 2. 3, negative 2. EA. To move from E to A, first move to the left. How many steps? 1, 2, 3, 4, 5, 6. And then 1 step upwards. So EA will be equal to negative 6, 1. Negative 6, 1. That is vector EA. Suppose we are moving now in the opposite direction. What would be vector AE? Now it's like you're now moving in the opposite direction. Now in this case, the starting point is A. The end point is E. How do I move from A to E? You can see that to move from A to E, you first move 6 steps to the right and 1 step downwards. So I will have 1, 2, 3, 4, 5, 6 to the right and 1 step downwards. So vector AE will be positive 6, negative 1. How about vector DA? Suppose there was a line drawn joining D and A. To move from D to A, you move 1, 2, 3 steps to the left and 1 step downwards. So DA, even if they are not joined, you can see that you can move 3 steps to the left and 1 step downwards. So DA will be equal to negative 3, negative 1. Negative 3, negative 1. So this is how we write a vector which is given as a directed line segment in component form, or writing it as a column vector. The other one is you can be given this. Then you are given a squared paper. If I say vector AB is 2, 4, can you draw that on squared paper? Let us move to that as our next activity. Our last activity for today will be drawing a vector and label it, given the vector in component form. I'll do for you the 3 examples. Then this will be